Alright, in this example we're going to solve for the horizontal displacement of a horizontally launched projectile, given that we know the height and the velocity. A ball is launched horizontally at 12.5 meters per second from the top of a building that is 67.9 meters tall. How far from the base of the building does the ball land? Alright, so once again we have our building. We have a ball being launched off horizontally. It's going to come flying down in a parabolic path, and it's going to hit the ground. It's going to travel some distance y downward and some distance x here, and the x is what we're looking for. So we're going to do our x direction and y direction t-charts once again. Write down all the information that we know. In the x direction, since it's launched horizontally, we know that its velocity in the x direction is 12.5 meters per second. We don't know its displacement in the x direction, because that's what we're looking for, and we don't know the time it takes for it to travel that distance. In the y direction, we do know its displacement is negative 67.9 meters. It's negative because the building is 67.9 meters tall, but the ball is falling downward, so that's a negative displacement. It's thrown horizontally, so the initial vertical velocity is 0 meters per second. It's falling in free fall, so that means that the acceleration is equal to little g, which is negative 9.8 meters per second squared, as long as we're on Earth. And again, we do not know the time. So, on the x side, we have two unknowns. On the y side, we have only one unknown, and the time has to be the same for both of them, otherwise this ball would have to be in two different places at once. So the x direction's time and the y direction's time have to be the same. So, keeping that in mind, I'm going to use the y direction to solve for my time. So, let me shift this over a little bit so we have a little more room to do our math and work out our problem this way. Alright, so on the y direction, we have our displacement is going to equal our initial velocity times our time plus 1/2 times our acceleration times time squared. This is one of our kinematic equations. Since our initial velocity is 0, that becomes 0. So our entire equation simplifies down to delta D equals 1/2 gt squared. And so we're going to multiply both sides by 2, giving us 2 delta D equals gt squared. And then we divide both sides by g, giving us 2 delta D divided by g equals t squared. And then I take the square root of all of that. So t equals 2 delta D over g square root. Now that I've done my algebra, let's plug in our numbers. So our time is 2 times our delta D, which is a negative 67.9 meters, divided by our acceleration, negative 9.8 meters per second squared. And then, of course, we take the square root of all that. Sorry about that. Let me try drawing that again, and hopefully my pen won't mess up. There we go. Okay, so we're going to plug all that into our calculator, and we're going to get an answer for our time equaling 2.67 seconds. So the time again over here and the time over here are the same. So Now that we know the time and we know the velocity, we can calculate our displacement. Because if velocity is our displacement divided by time, then velocity times time equals our displacement. So now all I have to do is plug in the numbers that they gave me in the problem here. My velocity is 12.5 meters per second, and I multiply that by my time I just calculated of 2.67 seconds, and that gives me a displacement of 46.5 meters. And there we go. So that's how you do it.